think one of the big challenges with visualizing data is how to communicate uncertainty or distributions. And not because the chart types themselves are overly difficult or hard to read, but because many people don't understand uncertainty, don't understand randomness, don't understand what distributions are, what a percentile is. So on today's episode of the One Chart at a Time video series, we have Will Chase to help us understand the Violin chart. It's a fairly different type of graph. It's hard for many people to understand how to read it. But again, with good annotation, good labeling, I think any reader can understand how to read the Violin chart. So Will's going to walk you through it, what it is, how to read it, and even give you some tips on how to make it. So Will, over to you.
Hi, John. Thanks a lot for having me. So today I'm going to be talking about violin plots. Violin plots are definitely not used very frequently. So I'm going to jump right in and actually just give you a quick example of a violin plot. So this is what you might call typical example. They're these little squiggly things that sort of look like violins, hence the name. What violin plots are is a way of representing a set of data points as sort of a histogram. So these are showing actually representing the probability density of a set of data points along this y continuous variable. So in cases where the violin is larger, that means that there is more data represented in this range of the y variable than, for example, this range where the violin is skinnier. So you can think of these essentially like histograms that are flipped vertically and then mirrored across this central axis. Now, a logical question is, what is the exact relationship between violin plots and histograms? And another related chart, which is the box plot. So up top here, we have the raw distribution of a set of data points represented as a histogram. And overlaid on that histogram, we have this smoothed line, which is called a kernel density estimator. Now, you don't really have to know exactly what a kernel density estimator is and all the math behind it. Essentially, it's just a way of smoothing out a histogram. But it's important to know this is actually what is represented in the violin plot. So this line in the violin plot is actually a kernel density estimator. Now, one way of showing this data in a summary is a box plot, like we have here in the center. Now, I'm not here to talk about box plots, but they are related to violin plots, so I will mention them. And now at the bottom, you can see this is essentially the histogram, the violin plot. It's just, like I said, reflected so that it's shown on both sides. And you can see here in the center, a lot of violin plots are often plotted with actually a sort of miniature box plot in the center of them. So one question is, why would you use a violin plot over a box plot? Well, there are a couple of advantages to violin plots. Most notably is that they can show multimodal distributions where box plots usually do not do a good job of that. So this is an example I like to show. Over here we have a set of raw data. So each of these points, these are all of our raw data points. Now this in the center is a box plot representation of that data, and this is a violin plot representation of the same data. You can see that right now all of these points have the same distribution. They all have essentially a uniform distribution, so not very exciting. But what is interesting is to look at what happens if this raw data changes to have a multimodal distribution where we have a higher density of data at a certain number of points along this distribution. In that case, you can see that the box plots in the center don't change at all. And even though the raw data is very different in all these cases, the box plots are going to show the same summary statistics. Whereas the violin plots, due to their smoothed histogram nature, you can actually see and pull out where are the peaks and where are the valleys in this raw data. Now, I'm actually going to go back here for a second and do something a little unusual. I'm going to tell you that you, in most cases, should not use a violin plot. So although they have this advantage over box plots of showing the multimodal distribution, the thing about violin plots is there's a lot of unnecessary pieces to them. So if you look at the difference between the histogram here and the violin plot, there's really no difference, right? This is the same as the smoothed histogram. The only difference is that it's reflected, which doesn't really serve any purpose except to make the shape look different, but it doesn't change the interpretation of the data in any way. It's just duplicating that data over an axis. And oftentimes violin plots are shown vertically, which can be a little bit disorienting for people that aren't used to reading them, just because we're typically used to reading histograms along the x-axis. So what I would recommend typically is that you use a cousin of the violin plot, which is often called a ridgeline plot or a joy plot. So in this case, you can see it's very similar to the violin plot, except that we've basically chopped off the bottom half. So these are just normal histograms shown for a couple of categorical variables, and then you have your continuous variable on the x-axis. And this allows you to show the histogram in a little bit of a less cluttered and a more natural way for people to read. People are just more used to reading this type of chart. So it's a little bit easier to interpret. However, I am going to bring up one situation in which I think violin plots really shine, and when I would highly recommend using them. So this is an example right here. Now, there's not a lot of examples on the internet of violin charts, so this plot is a little basic, a little ugly in my opinion, but the visual form, the graphical form, I think does a good job here. So this is a split violin plot, and this is where I would recommend using them. So in this case, let's go through this chart. We have the age distribution of social media followers. So our age is a continuous variable on the y-axis, and we have a categorical variable on the x-axis of different social media platforms. Then we have a further categorization of the data into male and female for each of those platforms. And here you can see they've done a split violin chart where on the right-hand side, you can see the distribution of female followers and compare that to the distribution of male followers for each of these platforms. So if you have a case where you have a categorical variable versus a continuous variable, and you have a further binary classification in your data, like male, female, perhaps start point and end point, or just some treatment A versus B. In that case, I think the violin chart is a great way to compare two different distributions. But in the case where you just have the one variable, you don't have that extra binary classifier, I would recommend that you just stick with the ridgeline chart. Thanks.
And thanks to Will for that great review of violin charts. Remember, this is another way to show the distribution in your data. And it might look weird and odd and totally different to your readers, but just remember that good text, good labeling, good annotation can help readers understand how to read even this seemingly totally crazy new graph. So come back tomorrow and we'll have more graphs about uncertainty and distributions.